Question number 10. A block of ice of mass m is at its melting point. Okay, so a smaller mass m of water at a temperature of T degrees Celsius is placed on the top surface of the ice and remains there. Now we are given that the specific latent heat of fusion of ice is L and the specific heat capacity of water is given as C. We want to write an expression for the mass of ice that melt. Note that the water or the droplet of water here is placed on top of the ice. Okay, so if the ice is melting, it means there's an amount of heat that the ice is absorbing to bring about that melting of the ice. Okay, and once the water is placed on top of the ice, we could also assume, or we could also suggest, that melting of the ice that is taking place is because there's an amount of heat that is being given off by the water and which is being absorbed by the ice. Now let's start first with the ice. So we can write that our latent heat of fusion, specific latent heat of fusion of the ice, is given as the quantity of heat that the ice absorbed divided by the mass of the ice. So Q1 here is standing for the quantity of heat that is absorbed by the ice to bring about the change in state. Note that when specific latent heat of fusion occurs, there's a change in state, but then there's no change in temperature. So that is Q1. And going to Q2, Q2 is where we are looking at the amount of heat that is given off by the water. So we can write an expression that the specific heat capacity of the water, which is given as small c, is equal to Q2, which is the quantity of heat that is given off by the water divided by the mass of the water times the temperature. So Q2 is heat lost by the water, or heat given by the water. And since the water is placed on top of the ice, you can say the heat lost by the water, or the heat given off by the water, is equivalent or equal to the heat that is absorbed by the ice to bring about the melting. So we can equate Q2 to Q1. And when we simplify, we are getting our mass of the ice to be equal to mass of water multiplied by the specific heat capacity of water times the temperature divided by the latent heat of fusion of the ice. Looking through the possible answers we have here, our correct answer obviously is A. So we circle A.